Sequences. So today I'm going to talk about sequences. In mathematics, a sequence is an ordered collection of objects in which repetitions are allowed. Like a set, it contains members, also called elements or terms. The number of elements is possibly infinite in length. So unlike sets, order matters. Exactly the same element can appear multiple times at different positions in the sequence. Formally, a sequence can be defined as a function whose domain is a convex subset of a set of integers such as, like, let's say 0, 1, 2, or 1, 2, 3, or like 0, 1, 2, n, or something like that. So that's basically a sequence. So now let's do something with this sequence. Like, what is this sequence used for? So there's like many applications to this, but I'm not gonna go into detail. We're just focusing on like what sequences are and how to use them. And basically, sequences, you usually just list out the terms in a sequence, and here's what I have: listing the terms in a sequence. And so when h of n is equal to 3 plus 1 minus negative 1 to the n, so you just like do 3 plus negative 1 to 1, 3 plus negative 1 to 2, 3 plus negative 1 to 3, and then dot dot dot, because it's infinite, right? Because it's n, and it's just a number, and it's infinite. You never know. So, and then you plug it in, and you solve it. So 3 plus negative 1 is, it's just 2, and then 3 plus positive 1 is 4. 3 plus negative 1 is again 2, and then it's just gonna keep going between 2 and 4, 2 and 4, 2, 4, 2, 4, 2, 4. So there's a dot 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 right here. So that's that. Okay, now let's try another one. But I still want to talk more about sequences. Like, sequences, like, orders matter. Like, they're really important, and there are many important integer sequences. The prime numbers are the natural numbers bigger than 1 and have no divisor but 1 themselves. These are the most commonly known sequence. Like, that's the most commonly known sequence. And an official definition of a sequence. So a sequence is defined as a function whose domain is a set of positive integers. So, like, let's say a function like square root of x. So its domain is only positive integers, unless, like, yeah, it's only positive integers. So you can use that as a sequence, and that's good. Well, so let's get to another example. So we're gonna do b of n right now. So b of n equals n over 1 minus 2n. So, and then you plug in 1 everywhere for first term. Like, you plug in 1, and just for n you plug in 1, and then for n you plug in 2, and then plug in 3, plug in 4, and then go dot dot dot, because it keeps going to infinity. So, and then you solve for it. You multiply the 2's and the numbers right here. So you get 1 over 1 minus 2, 2 over 1 minus 4, 3 over 1 minus 6, 4 over 1 minus 8, and then dot 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 dot, because it's infinite. And then you subtract 1 minus 2, it's negative 1, right? So it's 1 over negative 1. 1 minus 4 is 3, negative 3. So 2 over negative 3, which is negative 2/3, but yeah. And then 1 minus 6, 3 over, 3 over 5, negative 3, 3 over negative 5, and then 1 minus 8, 4 over negative 7, dot dot dot. So the final answer is going to be negative 1, negative 2 over 3, negative 3 over 5, negative 4 over 7, and dot dot dot. I mean, that dot 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 is really important, because it goes to infinity, and you can't just not put those dots, because it will show it, because it's a sign that it shows you that it's going to infinity, and it's really necessary to include it. Okay, that's it for the video.